Hi, and welcome back to my channel. This week we've got another problem, and that is trying to find the area of the pink triangle. Now, we're also told with this shape that the length A to E is equal to the length D to E. So AED is going to be an isosceles triangle. Can you solve this problem, and can you find the area of the pink triangle? If you want to have a go at this problem, as always, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I wanted to do with this problem is to introduce a new line. Now, a specific kind of line, and that is one that is parallel to this line FG. Now, the reason that I wanted to do that is because what we would then have is a right angle here, and we also have a right angle on the opposite side, okay, because those two lines are parallel. If we then consider ACD, that triangle, well, we've got a 45-degree angle, we've got a 90-degree angle, so the other angle must be 45 degrees, and we therefore have an isosceles triangle, so we could call those side lengths X, and we could then use Pythagoras to work out what that would be, because we know the hypotenuse is 12. So we know x squared add x squared and square root is 12. So we get x root 2 is 12. So x is 6 root 2. Let's put that on the diagram. Okay, now from there, I'm also going to introduce this line. Now, this line is parallel to the line AD. So BF is parallel to AD. Okay, now, I know from there that because those two lines are parallel, BF and AD, that I am going to have alternate angles there. So the angles that you can see at B and F are also going to be 45 degrees, and therefore we've got another isosceles triangle there. Now, from there, if we consider the two triangles, so if we consider EBF and EAD, well, they have to be similar triangles because they're going to have the same angles because BF is parallel to AD. And as we know, AED is an isosceles triangle. So they have to be similar shapes. We also know that E to F is a half of E to D. And so because we've got that scale factor of going from 2 to 1, the full length to half, we know that to get from AD, this length, to BF, we would do the same thing. We'd use that scale factor and we'd half the 12 to get 6. Now we've then got, like I say, an isosceles triangle, and we can work out these other lengths, which I've labelled Y, so C to F and B to C. And we're going to use a Pythagoras again here, so we're going to get y squared add y squared and square root it is equal to 6, and then solve that, you get 3 root 2. Now, you can see I haven't written down the Pythagoras way of doing it because there's another way, and that is because actually BCF must also be a similar triangle to ACD because it's got all the same angles. And so because we've halved this 12 to give us 6, if we halve the 6 root 2, we get 3 root 2. We get the other lengths. So there's a couple of ways of doing that part. Now, from there, we know that F to G is a half of B to D. Now, that is because if we consider EGF, this triangle, and then we consider EBD, those triangles again must be similar triangles because the lines BD and GF are parallel. The angle here and here must be the same. We've got a shared angle. Okay, and so the third angle must be the same as well. And then we've got a scale factor between our side lengths. Okay. Right. So because again, we have gone from a length of D to E, so half that, F to E, that triangle must be half as big, or at least the lengths, I should say, must be half as big. And so F to G must be half of D to B. Okay, so where we've got 9 root 2 here, we're going to half that to get F to G, and that is going to give us 9 over 2 root 2. Okay, let's put that on the diagram. Now from there, if we look at that pink triangle now, we've got all the lengths we need because we've got a base and we've got a perpendicular height. So the area of the pink triangle is a half times 9/2 root 2 times by 9 root 2, which if we combine those two brackets or multiply those two last terms, we're going to get 81/2 root 4. The root 4 will give us 2. 81/2 times 2 is 81. And then half of that gives us 81/2 units squared. If you tried this problem yourself and you were able to solve it, as always, put it down in the comments below. It's always great to share with myself and other people that are reading the comments. And share the video. If you think anybody else will be interested in this type of video and you think it's interesting, share it, send it to people. Send it to people you think might be interested in, or maybe you could do a better job, or maybe you could solve it in a different way. Now, all that's left to say is, as always, thank you. I keep saying that, as always, thank you so much for watching. If you like this video, drop a like on the video, please. It helps. And if you have not already, please do consider subscribing to the channel because that helps promote and boost the channel. Thank you so much, and I will see you next Monday at 5 p.m. for another problem-solving video. Until then, bye-bye.